This is just a short video to just deal with the types of graph that you'll encounter at GCSE science courses and how to choose which type to draw from certain data. First thing I want to have a look at is why we do a graph at all. Now basically a graph is a visual cue to show various things about data, and the usual things that you do a graph for is either to compare features. That one over in the top left is the deaths from heart disease in different ethnic groups, or you look for trends and patterns. Now the trend and a pattern are very slightly different things. The trend, which is shown down in the graph down the bottom, a trend is when the data heads in a particular direction for a period of time. So in this particular case, you've got the bear population in the Emerald Forest, wherever that is, and between 2000 and 2006 the trend is that the population is increasing. You could possibly say that there are two trends where you've got a steep increase here and a more shallow increase there, but there are trends. A pattern is not necessarily where the data is heading in the same direction. It may vary, but a pattern is something that is repeated. Now the graph here doesn't actually show that the pattern is repeated. It's the temperatures between 8 o'clock in the morning and 4 o'clock in the afternoon somewhere, but you can be reasonably confident that if you did that the following day, the pattern would be vaguely similar, and if it is, then that's a pattern. Now the types of graph that you've got, the first one I'll just have a look at is a bar chart or bar graph. And in a bar chart or bar graph, you've got blocks that are separate and represent distinct categories. The left-hand one was the one I showed you before. Now, you can draw the bar chart either vertically or horizontally, and there is no rules for which you do of those. It doesn't matter. Any bar chart could easily be drawn either vertically or horizontally. So most of the time the sort of default position is usually to draw it vertically, but it doesn't have to be that way. A histogram looks a bit like a bar graph, but it's slightly different. In a histogram you should really put the blocks together without any gaps between. And the reason that you do that is a logical reason. Is if you look at the x-axis, this hasn't got any labels on it, but if you look at the x-axis, you'll see that the data is in fact continuous. It's not completely separate categories. It's just the range of 1 to 25 has been divided up by the people doing this experiment, whatever it is, but the data is clustered into groups. So because the first group is 1 to 5 and the second group is 6 to 10, well, 6 comes right after 5, so it is sort of logical to put the block right after without a gap between. The other thing that you just ought to notice if you do these, one of the common mistakes you sometimes see at GCSE is that the categories must not overlap. You can't have 1 to 5 and 5 to 10, because if you did and you got a reading of 5, you wouldn't know which group to put it in. So you've got to have 1 to 5, 6 to 10, 11 to 15 and so on, and that's a histogram. Line graph is simply a series of points which will usually have a line on it. That's the name of it. Now they're separate points. The line, this particular one shows the points joined point to point. Sometimes you have a line of best fit. How you decide whether or not to do a line of best fit will be covered in a later video, but you've got two axes with individual points, and those points are joined in some way. There is another type of similar, it's not exactly a line graph, but another type of graph that you may see. I don't think you're ever going to be asked to draw one at GCSE level, and that's something called a scattergram or a scatter graph. And that is where you do have points but for any value on the x-axis you might have more than 1 point. So for example, if you take the value of 100 here, it's a little bit difficult to see, but there's a point there, there's a couple of points there, there's another one there, that may be 100, that may be 100. So for that value of 100 you've got more than 1 point being plotted. So it's impossible to, you can never draw a scattergram point to point. It would be like a dot to dot diagram. You can't do it. The line that's going through it on this is not really a line of best fit either, because it doesn't actually fit very well. It's what's called a trend line. Now a line of best fit is a type of trend line, but this is, it'd be better to call it a trend line than a line of best fit, and it just shows the general trend. As I say, you won't be asked. Scattergrams always involve, they come from masses of data, and in schools you would never collect enough data to draw a scattergram, although you might be asked to interpret one. So, alright, you have some data, you've got to decide what type of graph to draw. Now, in order to deal with that, you need to know a few terms, which you probably know, but I just want to check before we go on. You've got, if you plot a graph, you will have the independent variable on the x-axis, and the independent variable is the thing that you change. And then along the y-axis you've got the dependent variable, and that is the thing that you measure. Now, for choosing the type of graph, you can largely forget about the dependent variable. It's the independent variable that decides what type of graph you draw. So what you're going to do is decide whether the independent variable is continuous or discontinuous. Now, continuous means that if you take the smallest value of it and the largest value of it, any value in between is possible. So, for example, if you were measuring lengths of roots, you might have the shortest root that you measured, the longest root that you measured, and any measurement in between is possible, whether you've got it or not. Discontinuous means that there are very distinct categories. One of the bar charts I showed you early on was population growth in different countries. Now, you had Mexico, you had Russia. You can't have a country that is sort of half Mexico and half Russia, or a quarter Russia and 3/4 Germany or something. So that's discontinuous data. Now, so alright, you look at the independent variable and it's either continuous or it isn't. If it isn't continuous, if it's discontinuous, then that's straightforward. You draw a bar chart every single time. If it is continuous, then you have a choice to make. You can't. It could be either a histogram or a line graph. And the thing that makes the difference to that is the data grouped or not? And if the data is grouped, then you draw a histogram, and if the data is not grouped, then you draw a line graph. So it's relatively straightforward. I haven't included scattergrams on here because, as I say, you won't be asked to draw one of those. But it's relatively simple, and you must choose the appropriate graph for the data that you've got. So let's have a last look at the three types of graph and just show how that pans out in practice. So the graph on the left, the independent variable down the bottom is different races. Now, I know that it's possible, not races exactly, it's different ethnic groups certainly. I know it is possible to have somebody who is part of one race and part of another, but those are usually allocated a separate ethnic group of mixed race. That's not represented here. So you don't have something that is of various sort of degrees between white and African American. If they are somewhere between white and African American because of mixed heritage, then they're classified as mixed race. So they're categories, discontinuous data. It's got to be a bar chart. In the middle, you've got continuous data. You've got 1 to 25 on for your independent variable, and any value of that is possible. 1, 2, 3, 4, or even 4.5 or anything like that. But you don't draw a line graph because this data is grouped, and to show the groups you draw a histogram, and in this case the bars are up against each other because the data is continuous, whereas on the bar chart they're separated. Then you've got, last one is the line graph. You've got years down the bottom, and that is in effect a continuous variable, because 2000 is a long period of time. You could have, January 2000, February 2000, and so on. So you can have, strictly speaking, I suppose it's not between 2000 and 2001, but there is, it is a continuous variable of time. Time is always a continuous variable, so you draw a line graph. So it's relatively straightforward, just a few simple rules, but it's very important that you get that right, because in all the exam boards, in the controlled assessments, if you are asked to draw a graph and you draw the wrong type of graph, you're going to lose marks.